sorry, I didn't unmute. Yes, it's my pleasure to introduce our first speaker. A very interesting topic. It's kind of taken over. Blockchain. His name is Fabian Vera. Is a reservoir engineering consultant, currently working at Meyer and Associates. He is a bronze medal winner in the 2018 Open Earth Community Hackathon, and a marathon runner and a tenor singer. He holds a Master's of Science degree in Petroleum Engineering from Texas A&M University, class of 2012. Previously, he was a SPE-YP Secretariat and currently serving as SPE Permian Basin Study Group Program Coordinator. And with that, I'll let Mr. Fabian introduce his topic. Fabian, are you there?
Yes.
Oh, yes, and that's me. First and foremost, thank you for the opportunity. Let me put a presentation ready for everybody. And I hope this can put some myths and facts on the table, and people can embrace more and more this technology. Let me see how can I share this. Oh, it says the host disabled participant screen sharing. I need to share the presentation.
Francisco, can you hear me?
Let's do something.
Yes, I can. So I guess I need to give Fabian a co-host.
No, Fabian does not have to be co-host. You just have to get him access to the to share his screen. I thought.
Okay. First and foremost, while we are trying to finish these small details, please raise your hand if you are familiar with a blockchain. You can raise your hand on the participant chat, and I can see how many are familiar or not.
Go ahead, Fabian. I think you can share your screen.
All right, now we're doing it. That's nice. That's really nice. Good. Let's do this. It's gonna be like this. All right. Can you see it now?
No,
that is just right. Thank you.
Good. All right. Today we're gonna present a topic called unlocking blockchain myths and facts. We're gonna discuss about how small details can give you advantage of this ongoing technology, and more important, the applications. Right here. So this is our outline for today. We're going to discuss what is a blockchain, how many of them applying blockchain, more examples, and small takeaways. So let's go with the first part. What is a blockchain? What is a blockchain? There are many concepts out there, but the most important thing is that it's a medium for an end. It can help you to commit statements that allows entities to commit hard to fake or easy to validate statements. It can also help you to agree on reality, like entities from different nature can go on this network, follow a determined set of rules, and agree on statements. Can also allow you to replicate records. So for every entity keeps a copy of the network records without making overstatements. So it can be interpreted in many ways. But if we want to keep an abstract idea of blockchain, is that it allows you to do immutable ordered commitments. That's what is going on with that. But blockchain has some implications. Let's start with this. Blockchain can be very slow because with a low throw output has a high latency. It can have differing guarantees for different types of data and can be very complex to understand and use to the point that people can even fear it. But also implies applications because most used sparingly to bolster centralized system trust. Let me be more abstract. To bolster trust. You also must be aware that blockchain itself cannot rely for veracity, and also must hide the complexity from end users. I remember this quote: if you know something is going to work, explain that to a 5-year-old, and that is going to work. It has been a good process. Now, we also need to be aware that a true blockchain is really slow. It's really slow because a full state replication and execution requires for every node of the chain and executes everything to remain trustless and guarantees immutability. Blockchain as at large can be redundant, but robust gossip. Like the same word that has been shared among your friends that becomes a truth, it can become a redundant gossip. Each node from the blockchain that you build can see the same message from 16 to 20 times across an unrestructured people-to-people network, taking up bandwidth. We're going back to bandwidth later. Also, it can be really slow if you're waiting for an agreement, because every set of transactions needs to be seen and agreed upon, regardless of what you want to prioritize, safety, liveness. It can wait. In light of this, let's check some implications. Implication number 1 for a blockchain: bolster but not replace. Imagine like a fancy cake you happen to do, but you need something to cover it, like a cream. Well, it bolsters but does not replace. Here we find a decentralized system that wants to connect with a centralized system. The data anchoring keeps centralized systems honest and trusted. We're going to go back to what an honest system means later on. These centralized systems are connected some way, somehow, and this is a decentralized system. The fact that these are interacting after this decentralized system enters into the game bolsters the whole system, but does not replace each system. That's the concept. Another implication: no veracities guarantees in the real world. We have here 3 points, A, B, and C. On A, we say an event has been generated on the chain. Point B has been generated off the chain, but known to many. And C is generated off the chain, but known to a few, the selected few. We have provenance, immutability, and veracity. For the event A that was generated on the chain, you know it happened, so it checks provenance, immutability, and veracity. For the event B that happened off the chain but is known for everybody, you have provenance, immutability, and the veracity has to be checked. It can be a yes or no by the oracles. And something has been generated off the chain and known to very few. It can have the provenance, immutability, but the veracity will be on doubt. Even without veracity, provenance and immutability are powerful warranties to verify if an event actually happened or not. Why we're talking about the veracity of an event? Because a blockchain itself is built by nodes. As its name says, it relies chain upon a chain, node by node. So if a fake node happens, all of a sudden you begin to divert your chain, making a fork. Let's remind those concepts because we're going to revise them very, very soon. Track responsibility, not truth. I will say that one more time. Blockchain allows you to track responsibility, not truth. Let's check this example. Hypothetical supply chain data collection. There is no warranty of truthful data uploads, but you can trace who uploaded it. A manufacturer wants to have a chain of events from shipping, storage, retail to the end customer, and is hashing data and cryptographical sign and critical custody transfers to a smart contract. We're going to discuss this later on. And then you also can store data on your cloud storage, like sensor readings, GPS, inspection, and change of custody. In this picture, you can connect the step-by-step progression through a mobile app and receive alerts, validate raw data, and pull raw data and reports. When you receive a package from, let's say, FedEx or Amazon, you are tracking responsibility of who did what on a determined step. The same can be applied here. Now, if you mention that blockchain itself allows you to collect data that can be confidently believable, we need to see which has been the technologies in the past and the confidence that it gave us. On the x-axis, we have time or expense, let's say money or resources, and on the y-axis, we have confidence. The more confidence, more efficient, no confidence gaps. A very low level of confidence and a very low level of expense is your typical conversation, like a gossip. Something that can be a little more confident because it's already recorded is a message. And later can be an email because you already put something that is already recorded. And each person in the conversation, each person in the transaction has a record. And a layer, maybe a whisker, a little above is an Excel spreadsheet because now you are quantifying your statements. A little more, and then you have right now all these applications and some project management. Now, there is a confidence gap that can be between internal versus external. Any of you who have been in the oil and gas industry can remember when there has been a confidence gap, internal and external, between the client, say the operator, and the service provider, like the oilfield services. Now, we go a little more above in this y-axis, and you have operational data can be collected for external proof. And then you have the consulting firms that are providing professional services. And then you have the audits, the big four audits. Because when you are, let's say, writing an SEC letter, eventually your client will have an audit. And that audit requires data to verify the confidence of the data used to come up with the statements. And one more level can become litigation, but that is a topic that is beyond this discussion at the moment. In the big picture, we see that if we have a technology that can close the gap between internal and external confidence, can accelerate processes, can accelerate innovation, but also comes with a cost. Now, we discussed briefly what is a blockchain and how it can help us, in this case, close the trust gap. But how many of them are there? Fascinating the question, more fascinating the answer. How many of them are out there? let's go with the public permissionless blockchains. Those allows you or any user at any time to ledger management facilitated by a distributed network because it's public. Then you have a federated permissionless blockchain. Can become single or multiple industries that allows access to users based on the rules defined by a group of entities or consortium to participate in this network. Ledger management is facilitated by the consortium. We have private permissioned blockchains. Those allows you or any user based on the permissions set by the private network. Ledger management facilitated by a single company for private use. Mostly private applications, let's say contracts that has to be done without using paper. We can go later on those during the example. And we have also smart contracts, which are event-driven programs that run on a distributed ledger and can take custody over an asset on that ledger. The American philosopher called Joe Rogan remits very well this word, asset, a favorite word of him, because an asset can become anything. So it's up to the people who are building these smart contracts to define the asset. The embedded if then statement allows for an automatic transaction based on predefined terms. For example, a payment can be remitted when certain criteria is met, or a certain data set can be cleared upon a certain number of rows are met, or certain frequency is met. For example, a permanent double gauge can be accepted for analysis once it meets a certain criteria in data frequency. Now, let's move forward with some concepts that people need to know. Proof of work. What is a proof of work? And what is proof of stake? With this picture, it's going to help us to understand which are the inner consequences of applying blockchain. Proof of work is a consensus mechanism. Proof of stake is a consensus algorithm. In a proof of work, what you do is to add each block to the chain. Miners are allowed to compete to solve difficult problems using the computer processing system. In order to add a malicious block, you have to use a computer that is more powerful than 51% of the network. And first miner to solve the puzzle is given a reward for the work. What is a proof of stake? In a proof of stake, there is no competition as the block creator is chosen by an algorithm based on the user's stake. In order to add a malicious block, you have to own 51% of all the cryptocurrency of the network. And there is no reward for making a block, so the block creator takes a transaction fee. Why we're discussing this for blockchain? Because as you're creating nodes, you are creating chains because you allow that. There is good and bad people helping you to do and build this technology, to build this application, but you can also fork it. You can also make a deviation from the main idea, the main application in your technology. That's why proof of work is required, and proof of stake has to be required as well. Now we introduce some terms that people may confuse, like miners, like rewards, puzzles, cryptocurrencies. We're going to discuss that very soon. How many kinds of blockchains are out there? Once again, and then you have like hash, timestamp. We're going to discuss them right now. What is a hash? Hash, H-A-S-H, is a function that converts an input of letters and numbers into an encrypted output of a fixed length. This hash is created using an algorithm and is essential to blockchain management in cryptocurrency. What is a nonce? Nonce is an abbreviation for numbers only used once, nonce, which is a number added to a hashed or encrypted block. in a blockchain that, when rehashed, meets difficulty level restrictions. The nonce is the number that blockchain miners are solving for. And then we are going to ask again, why we're hearing about miners, why we need to hear about this. The role of the miners is to secure the network and to process every Bitcoin transaction or every token you want to do with your smart contract. Miners achieve this by solving a computational problem, which allows them to chain together blocks of transactions. Once again, miners achieve this by solving a computational program, which allows them to chain together blocks of transactions into the blockchain. Now, which is the role of this in the grand design? They are stakeholders in a blockchain. Miners are forced stakeholders needed for the system to work and extract value from the system and bring value because system design requires them to do so. Natural stakeholders are the ones that are paying the system's fees, like the maintenance of the system. Have a problem, the system solves and benefit from a reduction in the system friction. Now you see there is a small conflict between the same blockchain users. Let's discuss that very, very soon. There we go. In a blockchain, we have a trust versus efficiency. We have been discussing that a blockchain can allow you to close the gap between the trust, the confidence between the users. So we have a bandwidth that has an initial setup, that has a recurrent event, and then have a trust model. We have a full client, a light client, and an ultra light client. For a full client, the initial setup for a bandwidth is 250 gigabytes. Has a recurrence of 150 megabytes. How it throws a model? Connection to an alert node. A light client can have only 20 megabytes of initial setup and a recurrence of 5 kilobytes, but is vulnerable to bad blocks. An ultralight client can have 80 bytes of initial setup and recurrence almost nowhere, but can be totally delegated. So the trust versus efficiency becomes an issue, especially when you're having a blockchain project. Now let's go with some math for people who wanted to learn a little more. Proof encode a valid statement transaction for each of the chains, each of the blocks. A prover creates a proof using a previous state and a valid transaction between the chains, between the previous and the post events. A verifier user's commitment RTI to a statement SI to simply verify a very low CPU bandwidth. Those are maybe 1 or 2 slides is going to have these kind of terms. So rest assured. Now, we need to discuss a security assumption. Because remember, you can have a private blockchain or a public blockchain. A verifier must locate any prover who is honest and current from this block sub 0 to my block sub I. We can have a forking prover that is going to deviate your main chain, or you're going to have an honest prover. The verifier has to identify which are the real intentions of these two provers. And then, after we check again the clients, we have a succinct client. Then all of a sudden, its initial setup is less than 1 kilobyte, and the trust model is a connection to an alert node. This is one of the indirect metrics to really verify the commitments of your clients or of your providers of data into the blockchain you are building. And then you perform a proof of work. Remember what it was? To check inside the transaction for each block that you're building. So the honest verifier can actually check on the untrusted prover. And that's pretty much all the slides for the math that we are going to discuss. We discussed about the layer effect a miner has in your chain. Remember that we had unknowns into the system. A large miner and a small miner is going to have different degrees of difficulty. So the play the miner has is to actually find the nonce and make a proof of work. Of course, you see that for a larger miner into your blockchain, it's going to be easier to find the nonce and create a proof of work than for a small miner who has more difficulty or needs more resources as the larger miner to find the nonce and create proof, so then you can keep building securely your subsequent nodes in your blockchain. The intuition for this is that the search time versus the proving time ratio quantifies the problem. Here we have two events that happens on a blockchain itself. If you are finding the nonce and you use a large amount of resources and time, once you actually find it, it's going to be easy to create your proof of work. This short improving time is almost progress-free. What is a progress-free, you may say? Usually progress-free are events that are required to make a step-by-step without relying on what happened on the step before. That's the abstract concept. Here, in this scenario, it requires a slow rate of blockchain updates. Okay, so far so good. What about here? Finding unknowns, very short amount of resources, but to create a proof is large. In a long proving time, that is not progress-free because you are requiring a lot of time and resources to create your proof of work. And in the limit, fastest prover adds every block. This later scenario actually benefits the larger miners because they have larger resources. And it's going to be a bigger gap between your miners, a bigger gap between the speed of your blockchain, and so forth. What else we have? Now, a key idea, something that we can take from this, to prove generation as a proof of work puzzle, to find the nonce and create a proof. Those are lines that you can use on your code to start solving the problem. And keep the predicated unaltered. Remember that the problem is that we can change nonce without recomputing the whole proof and favors return to scale. But also the proof of work can be amortized between each of the proofs. And I promise this is the last slide we're going to discuss about these mathematical concepts. But yes, those are right now the state of art that people are discussing to accelerate and reduce the mistrust between the blockchains. And also, this can lead to another kind of problems. If a large miner and a small miner on the same blockchain have an equal amount of resources to create a proof, then they can have also different times to find a tweak in your future proof of work. Now, let's discuss some applications from blockchain. Once we discussed the benefits and also the consequences, there are studies that say that 88% believe this technology will disrupt the industry somewhere, somehow. 59% believe that disruptions take place within the next 2 to 5 years. And 74% are right now exploring opportunities. So, which is our current state? To learn and identify opportunities and start building pilots, and proof of concept tests, proof of work, proof of stake, and then evaluate scales by establishing participation, building capabilities, and implementing solutions. The transaction cost theory of blockchain. Whatever we have discussed so far can be also resumed in this plot, as the size of the blockchain event in the x-axis can be compared based on the cost. The number of participants and the degree of disintermediation can have a turning point where the total sum can actually give you the lowest of the cost between the transaction cost, the duplication and reconciliation that we already discussed, the peripheral trust, to establish a trust between the less trusted member, because you need to trust which are the miners if they're building your chain or they are forking or putting away the idea of your chain, and make a total sum. Now, for the amount of data, you get a proposition. You can apply projects based on importers, carriers, customs, banks that can go from production and transport demand to generate planning efficiency for the banks to create a credit profile and generate a value proposition of compliance, security, and transparency. This leads to the following. You don't need to create a token, a coin, to have a blockchain project, because you can solve a problem without generating a token at all. And that's something that people think, oh, I need to be into the crypto token business to have some blockchain applications. Not really. And these are opportunities that can help you accelerate innovation and close the gap among your players for the level of trust. Now, let's go for some applications. You can write your own Ganesh code with a virtual Ethereum blockchain, and you can create keys to guarantee private access. So I'm going to discuss right now some sectors that I've been playing with, like subsurface data, legacy wells, production inventory for the oil and gas, and also some other applications that has been involved recently. Subsurface development, because you have a heterogeneous data source that are connected to what offer providers with what a client can touch. So solving a data scarcity and a reservoir characterization project, or to determine the landing zone, can become smoother because all the historical data is available. And also to track their responsibility, who bring what data and how that data is helping you. So from this tip of the iceberg picture, there is, like, for example, current platforms, in particular service providers, that many organizations integrate data that can be deleted without notice. So you need to track responsibility, who bring the data and what the data can give to you. And you can connect that data from different servers to your chain. For example, these databases are often with different backgrounds and variable sources that are different in nature and also frequency. So one of the approaches was to integrate a database under a federal gathering system. So I created some web links to put them into the chain to make it more practical as data becomes more heterogeneous, and then normalize them. But those are topics that goes right now into a deeper level that was already ready for presentation in another topic. And then you can generate your Ganesh code and create different private keys. That was one of the applications. Legacy wells. When an inheriting company receives data that has been passed through the years, you can have data contracts on paper. Some of these data can be hard to read or even hard to integrate. So you can create a blockchain system to make it easier to track history of these legacy wells and optimize your processes. A digital gentrification of your acquired legacy data is something that was done with 1 or 2 private clients. And I have also something about production inventories, because a significant amount of time is spent on complying with regulations, and we don't know exactly what a particular place, a particular refinery is actually supplying. Are the numbers always the truth? So data at the end of each month into the specific regulatory reports are usually required. You can build your own blockchain to keep track and accountability of each of those time steps. And you can have an immediate effect, which is the real-time quantification of production inventories. We have also more examples that's been going on. Example, BACT. VAKT is a digital platform that processes deals, but it has an agreement between shareholders, usually requires them to be on the same page. But you can accelerate this because in the past you have inefficiencies of paper documents, limited operational risk, and you can eliminate the fraud if you apply a blockchain system. So in a post-trade securities clearing today, you have a lot of players. A central security depository, seller custodians, purchaser custodians, you name it. With so many players, there's going to be some information that can change between people. By applying a permissioned blockchain, you can start cutting corners, actually making things smoother, and to have lesser amount of medium players. You can build a larger blockchain, and you can also accelerate your steps, but also comes with a cost that was discussed in the previous slides. We also have another example, Congo. What it has, it represents an opportunity to make a saving cost on central financial reporting, 70% as a result of more streamlined and optimized data quality. And it has a potential cost for compliance between 30 and 50%. These are financial applications for financial transactions. But it has the opportunity to reduce up to half of your potential savings on centralized operations. Because what you look is not only to close the gap in confidence, but also to accelerate your processes. Another example that is familiar with the oil and gas business, Daragumbo. They focus to do the contracts, and they realize that between the service providers and the players, there is some degree of skepticism. What they do is to attack the lack of trust that are hold up efficiencies and cost savings, and they apply a blockchain to make agreements easier. I invite you to talk to them and to learn more from what they're doing nowadays. Something very interesting is the potential market size. For blockchain alone, in oil and gas, is around $2.6 trillion. And for other applications in other industries, in other commodities, like gold, copper, are around that scale. That's so far so good for industry like oil and gas. What about medicine? Well, it also got you covered. There is right now a lot of initiatives, like, for example, Consensus released at Hackathon to accelerate the search for vaccines or to create smart contracts that involve a population, hospital beds, ventilator use, and make things easier. Let's say you want to reach rural communities, but you don't have enough talent. You can apply a smart contract to connect the doctors and nurses from particular areas to help them, or to have an inventory of, let's say, ventilators or intensive care units, applying blockchain. there has been a lot of competitions going on and a lot of opportunities online that you can also get involved even right now. Now, there has been something going on recently that mail voting can become a bigger issue. No problem at all. The National Law Review already released a study that there is an ongoing trend to allow blockchain for remote voting. Actually, already happened in West Virginia and Colorado back in the midterm elections 2 years ago, and it really had promising results. Totally different and totally disconnected from what happened in Iowa. If you apply blockchain, you can actually make things easier without having the issue of a lot of paper for the mail-in voting. But please, don't believe whatever I say. You can do your research and you can find out what has been going on in this particular field. Another applications in current environment. Well, if your industry deals with complex ecosystems of stakeholders, like cross-border asset leasing or electric disruption equipment, you can think about using blockchain. You have to deal with rapidly changing processes and requirements like technology outsourcing or cross-border supply chains management. Think about it using blockchain. You have a distributed or transient workforces like construction subcontracting or any knowledge of workers on their devices, you can apply blockchain. If you are heavily regulated and regularly audited, like healthcare informatics or PPP infrastructural operations, you can apply blockchain to close the mistrust and to elevate the confidence among your players. Now, if any of you have been saying, that sounds good, but I don't believe whatever you say, well, remember, this is the tip of the iceberg, because the main idea to solve these blockchain problems is to streamline distributed work processes. The real deal is to eliminate coordination cost, to eliminate the cost of the middle people that are making the red tape, that are making the bigger problems among your solutions. Let me close with a statement by David Schwartz, CTO of Ripple, in his last presentation at the Stanford Blockchain Conference. Use blockchain to solve people's problem. Do not build friction into the system. Build it out of the system, which can be a very good point of view if we want to apply this across industries. Now, it's time to do some takeaways of the presentation. Blockchain is a technology, and Bitcoin is only an application. If you came with the idea that you needed to generate a coin, not necessarily, because the technology itself can allow you to do a lot of things beyond only tokens. 2, it helps you to decentralize and accelerates. The technology itself elevates trust among the players, but it also has a cost. You don't need to generate a coin to have a smart contract. Once again, people hear blockchain and they link it to what the tokens are trading in the market. Not necessarily, once again. And number 4, maybe the most important. You generate value by building friction out of the system, not building friction into the system. That can be something that can be applied to any aspect of life, to any industry at all. And with that, I want to close my remarks and thank you for the opportunity that we had to discuss this topic today. Thank you very much. Now we go for questions.
Fabian, great presentation. It's much more improved than the one we went through the trial. Do you remember? Very much appreciated all the feedbacks that you took from that time. Very nice. I really enjoyed it. Alex, would you please go ahead and check out the Q&A? What are the questions that people have presented to him, and have them present to Fabian, please?
Yes, Fabian, we've got a few questions here and comments. Let me see, the first one here is actually from Salim. can any member of the consortium alter any data without the knowledge of all other members of the consortium?
That was something we discussed in previous slides. It was, let me check, the proof of work versus the proof of stake. That's why you need to put a lot of value in resources to determine if something was really hard to find, the nouns. You remember the nouns? If something was really hard to find, or it was created in order to make the deviation of the chain, in order to alter the data without the knowledge of the members of the consortium. That's why you need to trust between the miners, between the people who are building the chain. That's why we have mathematical formulas to determine, is the chain actually going in the right direction? Is somebody trying to alter the data? Accountability, that's one of the main principles for the blockchain itself. That allows you to actually track this. I hope that answered your question.
Okay, we have another one here from Gregory Devenish. Says, please explain that a blockchain does not require a cryptocurrency. A cryptocurrency requires a blockchain, but a blockchain does not require a cryptocurrency or token.
Yeah, and that was discussed at the halfway of the speech. We discussed why we needed a miner, why we needed a proof of stake, why we needed a proof of work. If we wanted to do a token, but we can do a blockchain self project just to connect the data. Now, it's entirely up to you and your big idea. If you really want to tokenize your project and then trade your token in some other industries, it's entirely up to you. It's totally not correlated one with another. For example, why people want to enter into the Ether or Ethereum? It's because projects in Ethereum has been trading at a different level, but it's still compensation-wise better than other chains. For example, you have here the Bitcoin level, right? And then you have, wait a second, right here, you have Ether, and then you have other chains. The market value for those in order to trade is different. It's entirely up to you and your end. I hope that answers the question.
Okay, there's another question here from Celine. Which computer program is most suitable to develop blockchain technology?
The better question is, which project are you looking to build? And then you use the software required. Usually when we talk about languages, Python is a good one. Java is another good one. And then we go to applications. If you want to build applications, like you want to do some particular apps, there are different kind of programs. Let's say Truffle, let's say Tazos, let's say Corda, let's say other ones. And then you have already systems that are already helping you to build this Ether. It's entirely up to what kind of project you want to do.
Okay, I'm sharing some information here from Gregory Devenish. There is an oil and gas blockchain consortium. You can check it out at www.oocblockchain.com, and that link is in the chat if you want to look at that.
I totally encourage to be in touch with the people in the consortium. You can talk with them and have discussions on pilots. Totally agree.
Okay. And another one from Celine. Where do you find it will have most or best applications in the oil and gas business?
Let's go to the principle. Why you want to apply a blockchain? Because you want to accelerate innovation, because you want to elevate the trust among your players, because you want to reduce the confidence gap among your players. With that in mind, because you want to build friction out of the system instead of building friction into the system. That will help. That will help a lot on what kind of application in oil and gas. For example, You have a lot of data from your service provider and your client. Sometimes believe it or sometimes they don't. Okay, you can reduce the confidence, the confidence issue by building something there. Or you want to inject CO2, but you need to elevate the trust among your investors. You create a smart contract that can trace accountability, who puts so much CO2 and when, and you can even start to create value from it. It's entirely up to what problem you really want to solve.
Okay, we have a question here from Francisco. Are we ready for remote control voting without fraud?
Yes, absolutely. You may bring right now, that's total malarkey. I don't believe whatever you said. The MIT already gave a study. What other solution you have? Mail system has a problem that it requires paper and the processing itself. People can bring the issues that the Iowa app already brought to the communities. Remember, this is not an app. This is a technology. Go and search what happened in West Virginia. Go and search what happens in Colorado. The city of Houston has been in talks with Bradley Tusk and the people who deployed these solutions in West Virginia to be applied here for the incoming elections or the midterm elections of 2022. But most important is, do you really want to use it? Like, if technology really gonna be embraced by the people, like I remember people were saying in the past, who really wants to have a cell phone around you anytime? And now everybody has a cell phone. So it's about how much you want to embrace the technology and how much accountability, once again, can be among the players. And by the way, I almost forgot. We discussed about bandwidth, right? And it happens that we are about to enter the stage of 5G, which is a bigger bandwidth.
Mhm.
That's something that can be used, isn't it? I hope that answers the question.
Okay, we get one here from Gregory Devenish again. The value is in the immutability, which means you cannot change a record. You must write a new record.
Okay, that's good. That's a good thing.
Salim has a question
There
here.
is a question from Griffin before that one.
Oh, I'm sorry. Yes, here it is. Thank you, Francisco. Griffin is asking, what is PPP, as in PPP infrastructure operations?
Oh, that one. Or it's a public-private partnership, PPP or 3Ps, like a cooperative arrangement between two or more public sectors or private players. Sorry for not writing that longer.
I hope that cleared that up. If not, you can ask it again at the bottom. And returning to Gregory's question, the value is, that was the statement we read, sorry.
Mm-hmm.
Salim, Hannah has a question. Who are the leading players of the blockchain technology, as you know? Please expand on friction as we move to digital currency. Is blockchain needed to be, is indeed very, very helpful.
All right. The first question that says, who are the leading players on blockchain technology? IBM has been a good one for a long time. Now that we are in a state of technology that things and the processing power helps, is one of those you can talk with. Consensus is another one that is diversifying between health, between the supply chain and more. Ripple, RIPPLE, that's another big one that has been having a lot of consortiums with the universities that right now is hiring. So if you want to enter there and you don't have any work permit problem, you can go there and start talking with them. What else? If I'm missing something, please forgive me, but those are the big ones that I've been hearing a lot. Ethereum itself has been a big player as well. And you can find them usually every March in Austin for the South by Southwest. You can find all these players right there. And now, the question number 3 that says that we move to digital currency indeed will be helpful. Pretty much. Right now, we are in a state of society that contact becomes more and more hard to do. Even debit cards are like right now you tap it and now the proceeding happens. So that's something that it can be done. There is a project by a startup called Topel right there in Colombia. But then again, we have to discuss about the legal terms of what a central bank can do for a particular society. Going back to question 2, expand on friction. If you remember the physics concept of friction, that in a surface allows you to not move as smooth as possible, it can be red tape. But more important, friction itself in a system, when we say build friction out of the system instead of building friction in the system, it means if you have a solution, make that solution be for everybody. Like, can everybody benefit from the solution? Put an example. If you build something, let's say, how can I say? There is a particular kind of business that allows you to get information, let's say, to buy a house, okay? Or let's say you want to get admission for a particular program for education, name it. And you really want to get access to that information. There is certain kind of side of the business that they want to have that information for you to pay them. Like, this is a way to build a resume. This is a way to get information for your loan, or this is a way, but you have to pay us. It's like, I don't want to pay you. I don't want to generate that friction so I can go to the way I want to go. Because the last thing that this particular player wants is for you to be self-aware, for you to know how to do it and go to where you want to go. That's the friction. So you build a solution, you build the friction out of the system so everybody benefits instead of building the friction into the system. I hope that example helps to clarify the question.
So in other words, Fabian, what you're telling, eventually that will eliminate the middlemen, as what is happening with Amazon distribution. At the moment, all the middlemen are taken out. That's why you can get it at a more effective prices, all the commodities that Amazon is shipping out to you. And if you think about Amazon, eventually Amazon is going to be tremendously benefited from these blockchain technologies. That's correct?
Mm-hmm. Now, remember that these particular organizations have a mindset, but that's a topic for another talk. They don't believe in competition.
No.
They don't believe in competition because they see it as two ways. Either you have a monopoly or you have competition. And they only believe that they can overcome everything. But that's a topic for another discussion that is totally beyond the discussion we have today.
No, but I was beginning about the issue of middlemen. It takes away the middlemen, right?
Yeah.
Now, I don't know if there are other questions in there, Alex?
No, we've gone through all the questions that are on the chat.
Okay, and then I do have some of the questions for you, Fabian. Well, you and I work in the petroleum industry, particularly in reservoir engineering. And for example, we prepare the reserves report and reserves analysis, reserves reporting, and it goes to SECs for public companies. As you know, many years ago, probably over 20 years ago, Shell's CFO and CEO, they lost their job because they manipulated with the reserves numbers. So when you come to usage of the block technologies, can it prevent such things from happening going forward? Well, how do you see the application of blockchains in the reserves estimations as reserves reporting? Because if I want to buy oil and gas property, someone is selling it, I need to know what reserves is in there, how much has been produced, and how much is left, so that I can decide what price I'm going to offer. So is the blockchain is going to give me the complete transparencies to understand and cut out the middleman or the manipulations and get right down to the nitty-gritty of the exact valuations. Of course, this is a science. Reserves analysis is not an exact science, as you and I know. So what is your comment on that?
You already answered the question. Because you are already tracking by accountability each of the persons that were involved in the reserve assessment every time it was assessed. By the time the audit arrives, it goes to the chain and finds who were the accountable people step by step every time.
Mm-hmm.
I hope that answers the question.
Well, sort of. Yeah, I'm not fully clear about that particular issue yet. Anyway, we can have those discussions later on. If there is there any other questions for Fabian at this time?
Well, I have one question. Hi. The question is very simple. So the blockchain can be applied a step lower of what they just is being discussed, which is gathering the information, the data acquisition system that is gathering the information, it needs to be validated. So therefore, you need to put a blockchain on the validation of that data? Or how can you make sure that the person or persons that they gonna see and oversee that data, can they validate how trustworthy it is? Let's say, you know, the data is corrupted because you see something that is not quite right on one of the nodes or one of the data points. Can blockchain really be accessed to that point, or is just between humans, let's say?
You are mentioning right now the reason why blockchain has the proof of work.
Correct.
Yes, to add each block to the chain, people who was involved in this building of the blockchain really compete to solve the puzzle, which is this information reliable, or is this information from a malicious block that wants to steal the data? That's why you have the incentives.
Fork it, as you said. You know, you can fork, but at the same time, you can manipulate the data, and you know that manipulation will go to the ledger that you mentioned. As the manipulation of the data goes to the ledger, and you know, let's say that I opened that Excel and I did some corrections because the data did not seem to be logical, you know, some of the data points. The validation then goes through me because it's the reality that I'm seeing. I'm putting in that blockchain or that data to be verified of validity. You understand? You know, every single person needs to be valid throughout the whom the reality on the blockchains is always going to exist within the people that is only seeing it. Otherwise, it would be argumentable to other people that, for example, they don't know me and I manipulate that data.
Absolutely. That's why some applications can be slow, based on the verification of each step, based on the verification of the accountability of each of the blocks.
Okay.
That's why some applications can be quicker, others can be slower.
Okay, thank you. I understand. Thanks.
All right, thank you.
Fabian, did you mention that Microsoft is one of the companies which is moving towards blockchain?
I didn't have that on the record. You can pull the transcripts. What I saw on the picture that you were watching is that as on the x-axis you have what was the consumption expenses of time. Let's say you were sending an email or you were sending a message, and then you have the confidence in the y-axis. But right now, it's Amazon that is the one that is looking more into application of blockchain. You can also have people right now in the oil and gas division of Amazon playing with this technology at the moment.
Mm-hmm. Yeah, I saw some which mentions that Microsoft is also moving towards it because they don't want to be falling behind. As you know, 2 years ago, Microsoft stock price was holding on the same level, around $50. Now it is, look at it, 145 or something more than that. It's moving is because it's grabbing a lot of new technologies with the new CEO coming in. He's pushing for new technologies and all that. Thanks a lot. Are there other questions, Alex, you find, or are there other individuals, attendees, who would like to pose other questions to Fabian? Because we're coming close to the time by when we will have to move to the second speaker.
Yes, I don't see any additional questions there, Celine.
Thanks a lot, Alex. Thank you so much, Fabian, for a fabulous talk that you have presented. We hope to see you for other interesting presentations in the coming months and years. And
Muchas gracias por la oportunidad. Un saludo a la familia. Thank you very much, and I hope everybody stays safe.
Thank you. Thank you.
Thank you, Fabian.
Fabian, thank you.
Thank you, Francisco. Let's move on to the next speaker. Is Shahid, are you already there?
Yes, I am.
Okay, thank you so much.